Hello everyone, my name is Anya, and today I will be reviewing the use of artificial intelligence in mental health care. So, as of now, AI is currently able to help therapists diagnose, monitor, and treat patients. This is a huge step up from when AI was only used in conversational agents to talk to patients. However, with the progression of new technology, there is a fear of bias and compromised privacy from the system. There are also concerns regarding AI's capability and its efficiency in emergencies. In this presentation, I will overview the background and applications of AI in mental health care, a case study in which AI was used to help train future therapists, and concerns of using AI in mental health care. So, some background and context of how AI came to be in mental health care. A need for AI in mental health care surged during the pandemic and during lockdown when there was a shortage of therapists and an increase of patients due to isolation and reduced social activity. Mental health care has also long been inaccessible to many people due to socioeconomic and geological reasons. People have either been unable to afford a therapist or have not been able to access one due to being too far or just there not being enough therapists. AI in mental health care started in the 1950s with ELIZA. ELIZA was a conversational agent developed by Joseph Weizenbaum at MIT's lab. Though Eliza was considered to be fairly intelligent, she was not able to do more than just talk to patients and other users. After that, the Dendral system was created in the 1960s, which was initially used to help identify molecular structures in the biomedical field. However, its ability to use its own reasoning and judgment supplementary to numerical calculations found its way into mental health care with diagnosing and making predictions on patients. After that came expert systems in the 1970s and 80s. Expert systems contain a database of predefined rules that can imitate the decision-making abilities of humans, meaning they can take inputted data from the user and calculate the probability of a patient having a certain condition. Diagno was the first example of such an expert system. So how exactly does AI work? AI is trained on data and learns patterns through these data. It can be trained through supervised or unsupervised machine learning. Through supervised machine learning, the algorithm is already given labeled data to learn from, so the algorithm can find patterns to associate certain factors with specific labels. These labels are essentially the answer key for the model, as they tell the algorithm what the correct diagnosis would be if given a specific set of patient data and symptoms. Unsupervised machine learning teaches the algorithm how to group data by finding patterns in unlabeled data sets. The benefit of this method compared to supervised machine learning is that unsupervised machine learning prevents a bias in the AI, meaning that predictions are not based on prior knowledge and prior diagnoses from given data. Both supervised and unsupervised machine learning can be used to train deep learning algorithms, which pass raw data through many different layers of artificial neural networks. These ANNs function similarly to how the brain does in order to learn and memorize the importance of each factor of inputted data on the output. Algorithms trained by this method most closely resemble the human thinking process and allow the algorithm to create predictions based on more complex data sets. Another application of machine learning is natural language processing, known as NLP. This is a field of AI that uses machine learning to take in different types of input, such as text, speech, and writing, and makes it much more useful to therapists who can use it to process notes or conversation recordings in order to help diagnose patients. So, some methods and applications of AI. AI is trained on the basis of CBT, or cognitive behavioral therapy. CBT is mostly used to treat patients with depression by eliminating the negative thought cycle. This method allows for a therapist and a patient to work together to gain awareness of their feelings and thoughts and examine those feelings and thoughts so that they can strategize alternatives to promote a more beneficial state of mind. AI is able to help the therapist in many different ways, which include taking notes from a recorded or live session between a patient and therapist, monitoring a patient's mental health through their online and social activity or through their online conversations, and diagnosing and treating patients. AI is able to help diagnose a patient by taking information either from the patient itself or from information given by a therapist and using predetermined data to give back the most likely condition that they have. They're also able to treat patients by using whatever mental health sickness they may have and formulating the best possible treatment plan for them. AI can also help the patient. AI technologies are more easily accessible than regular therapists and are typically cheaper as well. They also eliminate social discomfort for people who are uncomfortable talking face to face to another person. A case study in which AI was used to help therapists is one that was done at the University of Utah. This was done using a conversational AI tool called ClientBot, which was evaluated on its ability to train future therapists. Traditionally, training future therapists is very inefficient and takes up a lot of time. Therefore, ClientBot was made to see whether it would be able to train a future therapist the same way as the regular training process for less time and with more efficiency. So how does ClientBot work? ClientBot uses two LSTMs, or long short-term memory models. The ones that ClientBot uses are sequence-to-sequence models and simple models. What a sequence-to-sequence model does is it uses beam searching to take the input of the trainee and decode it word by word to figure out and formulate what the best response to that would be. It uses the encoding and decoding method, where the encoder takes the important information from the input and uses neural networks to find patterns in the input to figure out its overall meaning. The decoder then uses content from past responses and takes the meaning of the input to deliver the best possible output. Simple LSTMs compensate for the fact that sequence-to-sequence models are unable to formulate very long or complex responses. These models make a prediction regarding the best response using information from a data set that it was trained on. Looking at this diagram, we can clearly see how the ClientBot works. In the ClientBot, the user plays the role of the therapist while the ClientBot plays the role of the patient. After the user inputs a question to ask the ClientBot or the ClientBot does two things simultaneously. It dissects the question that the user asked to determine whether the question was open, a reflection, or closed, and it also gives the user the best response that it can think of based on training data. Afterwards, after looking at what type of question the user asked the ClientBot, it will then determine which question the user should ask next. So after looking at the results of the ClientBot, it was found that those who received training from the ClientBot responded much better in certain situations than people who did not receive training from the ClientBot. So looking at the results, we can see that for open questions, the control group did better than the treatment group. However, when it came to reflection questions or open questions, the treatment group did better than the control group. This experiment was unrepresentative of what a real conversation looks like between a patient and a therapist in comparison to just chatting via text. There are many risks and concerns that come with introducing AI to the mental health care field. The biggest concern is bias. Looking at this table, there are many different ways that bias can enter the system. It can come from inequity in society, misrepresentation or misinformation in the data and the development team, biased models, differential outcomes during evaluation, and it can come from a biased use of the AI where the user only confirms pre-existing bias in the model. Some harmful effects of bias in a system include incorrect predictions and treatment solutions. Another concern for using AI in mental health care is privacy, where there's concern for information being leaked from patient monitoring devices and a breach of patient confidentiality between the system and the patient. There are also worries that an AI system will not be as effective or sufficient in cases of emergency or even potentially life-threatening situations. There are also some solutions that have been thought up in order to combat these risks. The first one is transparency and explainability, which is outlined by the WHO as explaining to users or making publicly available to users how the program works and exactly what it does. Another possible solution is considered human in the loop, in which a human is able to monitor and correct an AI system during the operation programming so it can fill in gaps or misinformation. Some existing regulations, or one that is set to be put in place, is the AI Act in Europe, which bans high-risk AI systems and carefully monitors the use of other systems based on how risky or threatening they may be to a person. So to conclude, there is a great potential for AI in mental health care. It is currently able to do many great things, such as diagnose, treat, and monitor patients. However, in order to progress and advance this technology further, we will need to address potential risks of using AI. These are my references for my presentation. Thank you for listening.